Hi, everyone. Sophia told you about me a little bit. I will be presenting my research on iterative text editing done together with my excellent co-workers and collaborators over the past year. As a disclaimer, this is not currently part of the Grammarly product offerings just yet, but rather it's an independent research exploration into how us humans, we revise text and how we can make the process more efficient and effective. So to give an overview of the talk, I will first describe the writing process. Then I'll go over the task of iterative text revision. I'll describe the framework that we built and our findings for iterative text revision, which will be followed by conclusions and upcoming future work. So let's talk first about the writing process. So there has been extensive research done on the theory of writing dating as far back as the 80s. It describes writing as a complex and effortful cognitive task. These where writers have to balance and orchestrate three different cognitive processes. There's planning, there's translation, which is getting your ideas onto paper, and then there's revision, which is mostly what Grammarly has been involved in. However, contrary to this theory, in practice, the writing process is much more complex. It jumps ahead and leaps behind. It's not linear, it's actually recursive. And as we write, we may jump ahead to a later stage of the writing process. And this work, it focuses on text revision as an essential part of the writing process, because revision enables writers to deliberate over and organize their thoughts, find a better line of argument, maybe learn some new things, and discover what was not known before. Specifically, it involves identifying discrepancies between what a writer wanted to write and what was actually written, and deciding what edits to make and how to make those edits. So while text revision is a strategic and adaptive process, it's more importantly an iterative process, as you see in this visual. And us humans, we are not able to simultaneously comprehend all these demands and constraints of text revision when we want to produce well-written text. For instance, we want to express some ideas, we want to cover all the content, we want to follow linguistic norms and discourse conventions and so on. So because it is so challenging to balance all these requirements, humans tend to make successive iterations of revisions to reduce the number of considerations at each time. So at every revision, humans will tend to focus on a subset of all these constraints. And then that's what leads to this iterative revision process. I think one piece of evidence that I've forgot to add here is you might have seen the recent paper from Microsoft on GPT-4, Sparks of AGI. They also touch upon this point that for converting one piece of text to another, yes, all of these large language models are great, but us humans, we ourselves get to know more as we revise, which is why revision in iterative revision is still an unsolved problem. So in this section, we dive deeper into the task of iterative text revision, and we provide a peek into how we formally define the task and its building blocks. So the key components are, the first thing, what we define is an edit action. It's a local change applied to a certain text object. Local changes include, you can insert, delete, modify, and operate at different granularities, word, sentence, paragraph level. So you could insert a sentence, delete a word, modify entire paragraphs, and so on. So this is edit actions. And what I show is how it happens in different domains. The second building block is edit intentions. So an edit intention reflects the revising goal of the writer when making a certain edit action. So in this work, we assume that each edit action will only be labeled with one edit intention. So on the right, you can see different kinds of edit intentions. You might want to delete information, update some facts, fix grammar, and so on. And finally, we define a document revision when a set of edit actions, which are conditioned by their respective edit intentions, when they're applied to a document, it leads to a new version of the document being created. So a document in practice will typically undergo multiple iterations of revision, which is exactly the process that we try to study and model in this work. So how did we approach this problem? How did we model iterative text revision? First, we created a new edit intention taxonomy, which I'll go into more details in the next section. Then using this taxonomy, we collected complex text editing annotations with crowdsourcing across these different dimensions. And then using this data set, we computationally model the process of text editing and using state-of-the-art text editing and text generation techniques. And finally, we built a human-in-the-loop text editing system to make the revision process more interpretable and efficient. And by analyzing the edits made by our text editing models and comparing them against human editing patterns and text quality metrics, we take step forward in understanding and exposing the challenges to computationally model iterative text editing. And feel free to interrupt me at any time in case you have any questions. So let's dive deeper into the edit intention taxonomy that we propose. So we first collected and analyzed thousands of raw documents across 3 domains, which I touched upon briefly earlier, and their edits. We then came up with a new edit intention taxonomy to model this process. So at the highest level, we categorize edit intentions into ones that change the meaning of the text and ones that preserve the meaning of the text. And since our goal is to understand edit intentions that improve the quality of writing, we focus on the second category further. So we divide that into 4 subcategories: edits that fix grammatical errors in the text, edits that make the text more concise, more readable, more understandable, edits that make the text more cohesive, logically linked and consistent as a whole, and finally, edits that convey the writer's writing preferences, including their emotions, their tone, their voice, their cultural context, and so on. So in summary, this edit intention taxonomy that we propose is generally applicable to any sort of different domains. They are applicable to different edit action granularities, word level, sentence level, paragraph level, and different revision depths. So it's pretty generalizable. So speaking of using this taxonomy, then we collected a crowdsourced data set. So we first collect a huge set of raw documents where each document comes with its revision or version history. We looked at 3 different domains: Wikipedia, archive for scientific papers, and news articles. All of the interesting thing about these different domains is all of these contain texts which are iteratively edited and persisted as new versions. So for each document, we sort each version according to its timestamp in ascending order. And for each document, we pair 2 consecutive revisions, 2 consecutive versions as one revision. So version 1 and version 2 are paired for revision depth 1, version 2, version 3 are paired with as revision depth 2. And for each sampled revision, now what we did next was we extracted the full set of edit actions And then we used Amazon Mechanical Turk to crowdsource edit intentions according to our proposed taxonomy. So in this case, you can see the edits that were made and each of the annotations that were collected using crowdsourcing. And then we use a combination of human annotations and intention prediction models to scale up these annotations and finally build a large-scale data set. So as you can see, our data set of iterative editing is large scale, much more diverse in terms of domains, works on multiple granularities, and revision depths. And also we release the edit intention labels, in case somebody wants to develop this corpus further. And yeah, so a little bit into the details of this data set. So across all, in this figure, we show how edit intentions are distributed across the data set. So across all the three domains, authors tend to make majority of edits at revision depth 1. However, the number of edits rapidly decreases at revision depth 2 and very few at depths 3 and 4. And we find that clarity is one of the most frequent edit intentions across all domains, indicating that authors really focus on improving readability across all domains. And similarly for archive, you can see meaning change edits are also quite frequent, which indicates authors focus on updating the contents of their abstracts, like sharing new results or updating facts about their findings and so on. For Wikipedia, we can find that fluency, coherence, meaning change edits are roughly similar frequency, which indicates they have much more complex revision patterns. And for news, we can see that fluency edits are equally emphasized, which indicates that improving grammatical correctness of the news articles is just as important. So as one of the first steps, we analyzed how do these revisions affect text quality? And to answer that question, we ran 2 human evaluations with linguistic experts. And we find that generally, human revisions improve the overall quality of the original documents or the overall score, but style edits degrade the overall quality of the original sentences. And this observation also makes sense since style edits reflect the writer's personal writing preferences according to our taxonomy, which may not necessarily improve the readability, fluency, or coherence of the text. However, these edits are still important to convey the writer's tone, style, or intentions accurately. And we also evaluated these texts by automatic metrics, and we find that these metrics are not that well aligned with human judgments, which is an indication that we need to explore other effective automatic metrics to evaluate fluency and coherence on documents. All right, so to summarize this section on the data set, we generally find that human revisions improve the overall quality of original documents. And then clarity is the most frequent edit intention across all sorts of domains. And there is a need to explore other effective automatic metrics to estimate text quality in documents. Now, given this data set, how did we model the task of iterative text revision? So what we propose is a 2-step approach to text editing, where we first perform edit intent classification, where we predict the spans that need revision and the type of revision that's needed by this edit intention. And then for the predicted sentences or spans that need a revision, a text revision generation model makes the actual edits, leading to a new document revision. And one thing to note is that we include the predicted annotations here. So in the first stage, this blue-colored text was predicted to have to need a coherence edit, and these green-colored ones were predicted to need fluency edit. And we included these predictions of edit intentions, and gave that to the revision generator, and that's how it led to a new revision. So here we see in a bit, so how does it work with in the iterative setting? So we see that given a document with n sentences, we take a context window of k sentences. I've shown that here with k size 2, so every 2 sentences. We first predict the spans that need revision and the type of revision needed by edit intention. And then for the predicted sentences or spans that need revision, a text revision model makes the actual edits, leading to a new revision. So here you see it at revision depth 1. Same thing happens at revision depth 2. And then finally, let's say this process keeps iterating till the system predicts that there are no more edits or revisions to be made. And that is how it works in the iterative setting. So how well are we doing on these tasks? So through experiments, we show that our system outperforms the previous baseline models in both automatic and human evaluations. In the first figure, you can see it outperforms on all edit intentions as well as the overall metric. And on the right-hand side, you see human evaluations where we basically recruited 3 different linguistic experts, asked them to annotate roughly 200 documents at different revision depths. And they evaluated not only our model's predictions, but also predictions that came from that were originally there, which humans had made. And they consistently rated our system to have higher quality of revisions. So we also shed some light on the behavior of text revision system by iteratively applying this to a set of essays. So on the left, we have edit intention trajectories. We just tracked what revision intentions were applied to essays. And on the left, it is when the system is applied to make revisions on essays written by students with intermediate level of English. And on the right side, you see a similar setting, but the essays are written by students with a good command of English. So we can see that the system makes fewer revisions for fluency for essays written by the latter group of students, which gives a peek into how it helps with effective writing for people with different kinds of writing assistance needs. So it is adaptive to the kind of text that comes in. So to summarize, we show that edit intention annotations are helpful in making text revisions. Modeling this task is quite challenging. There's still, in spite of the results that I showed you, if you go through our papers, there still exists a big gap between the best performing model revisions and human revisions. And finally, our system is able to learn to perform iterative revisions, and it can learn when to stop revising, which is a pretty interesting takeaway. And finally, let me dive into the UX aspect of the process of writing assistant. So we have built this model which can perform adaptively this iterative text revision. How can it help a writer write more effectively and make the writing process more efficient? So what we did was the following. So given an initial document, a typical writing assistant system will go through the sentences, identify possible edits that can be applied to each sentence. So the documents are revised using these suggestions. Then the system will keep on iterating and creating new revisions. And depending on the stopping criteria, something like, no edits are found, the process can continue or stop. That's how typically this iterative process will work. But what we did was we built this system which leverages human feedback to filter out the noisy edits at the revision stage. So this user or writer can actually review kind of like how a user interacts with Grammarly, whether each suggested edit, do they want to accept it or not? And the process continues iteratively, similarly. So instead of in the previous setting, the model doing all the edits by itself, now we have human in the loop to review the different edits that are suggested. This is an example of how that works. So with this system, we hope to achieve the following. We want to improve the writing experience by helping them focus only on parts that need their attention. We provide writers with fine-grained and interpretable edit suggestions. And by doing so, we improve the efficiency in revision with fewer edits and iterations. And we'll present some of these experimental results. So we validated these goals by the following two research questions using a user study. The first one is, does a writer get a good revision experience by using our system? The second one is, does our human in the loop system help produce higher quality of revised documents? Similar to the previous human evaluation, we hired 3 linguistic experts as our users to interact with our human in the loop text editing system. And to compare the model generated edits with human written edits, we provided them with 2 separate sets of suggestions, the model generated and human generated. And when interacting with the system, they were not informed about the source of edits. They were only asked to accept or reject edits and did not have any control over the stopping criteria. So in our experiments, we set the stopping criteria as either no new edits were made or we reached a revision depth of 3. So in this case, we found that the first research question was calculated or evaluated by calculating the user's acceptance rate to the edit suggestions. And a higher acceptance rate indicates that the generated edits were more meaningful and helpful to the users. And as shown in the plot, the green bar is the user acceptance rate to human-generated edits. Blue bar is the user acceptance rate to system-generated edits. And we find that our system is able to generate comparable edits with human revisions, which shows that iterative text revision, like the system can improve text quality. And in addition, we further asked them to take a feedback survey, rated our system on a scale of 1 to 5 in terms of convenience, satisfaction, productivity, and retention. And we find that they generally think our system can help get them to a more convenient and productive revision experience. The low satisfaction score is because they found a lack of domain knowledge in terms of the documents that they were evaluating. And this could be addressed by asking users to revise their own documents, obviously. And low retention score is because of some gaps in user interface. This was done as an independent research. So obviously, the quality of UI was not that great, and that's something we plan to address in future work. Coming to the second question, does it really help produce higher quality of revised documents? We answered this question by removing human interaction from our 3 systems. So we removed the user interaction in reviewing the model generated edits, which gives us the system only baseline. And we asked a group of another 3 annotators to judge whether the final revised documents have improved quality. And the results show that when the system human interaction, which is our proposed system, and this is just without human in the loop, This one generates, on average, a lower number of revision depths, which means fewer iterations are needed for revisions on average, which indicates that it's more efficient. It makes the process a bit more faster and efficient. Similarly, there are fewer number of edits to be reviewed, which again makes it more efficient. And in terms of quality, the outputs were rated much higher on average. So yeah, all of this together indicates the effectiveness of human feedback in the iterative text revision process, which can help filter out noisy edits and improve the quality of the final revised documents. So in conclusion, we proposed a taxonomy of edit intentions, which generalizes to multiple domains, granularities, and revisions. We collected, annotated, and released a large-scale, novel, domain-diverse, human-annotated data set of iterative revisions. We computationally modeled the process of iterative text editing using state-of-the-art text editing and text generation techniques, and understand and expose the challenges. I didn't go into a lot of details on the models, but happy to share further. What kind of models did we try out, and what was the performance on different tasks and so on. And finally, we analyze the user experience behind human editing patterns and provide insights into how we can make the writing process more efficient. So in terms of future work, we are working on better quality of data, achieving better alignment with experts and users to learn what does high quality text mean. So we are exploring this direction of using reinforcement learning with human feedback for the domain of text editing, how we can align human preferences with large language models to make this process even better. We are obviously the one big learning that we had from the modeling part was our system is still very fragmented and split into different stages. So how can we if we use better quality models, can that gap be addressed, especially in terms of things like fluency or grammaticality and so on? This is again something that we are exploring. There are ideas around instruction tuning that we are also looking into. And finally, how can we develop better ways to learn about user preferences? This is linked to the first one, but this is more focused on better user interfaces, so as to provide much more higher quality feedback in the process of iterative text editing. And that was it. Thank you so much for listening. These are basically the different papers that made up this talk. And yeah, I'm happy to answer any questions.
Yeah, thanks, Vipul. I see a couple of questions on our chat, and also, guys, if you have a question, you can unmute yourself and ask directly. So let me start with the questions from the chat, and then we can have a conversation. So I see Shane is asking, what text quality metrics or benchmarks exist? How to measure the quality of the text?
Yeah, so there are two ways to do that. I think part of my initially when one of the things that I focused on earlier was about how the automatic metrics are very limited. So to first answer your question, there are two ways to do that: automatic metrics and human evaluations. Automatic metrics are not that great for this. Even though, I mean, there's people use them, ourselves included, because there's nothing better that exists. Let me try to get to that slide. Yeah, So this is kind of how we evaluated our data set. I didn't go into the model quality, but I can open that up. Yeah. So this is basic. This is the paper, and all right. The metrics that we reported for our models were SARI metric, which is originally came from text simplification, but has gotten more popular in terms of just measuring general purpose text editing tasks. It looks at additions, deletions, preservation of different components of the text. So it currently is the top choice for such tasks. We also reported on Blue Score, but it's not there's a lot of problems with reporting Blue Score. Similarly, we reported on Rouge. And these are the different models that we tried. We compared against the previous state of the art from system from Google called Felix. But we experimented with BART and Pegasus models. So this is about the automatic metrics. Then we conducted a bunch of human evaluations as well. We gave them two pieces of text. One was human generated, one was system generated, and asked them to pick which one is better, and asked them to rate them in terms of whether it was fluent, whether it preserved the meaning, whether it was coherent, whether it was readable, and the overall quality. So yeah, that's kind of rather long answer or a detailed answer to your question, but I hope that answers it.
Yeah, thank you. So I see another question. How did your team make sure that the data set wasn't biased because of some individual like writing style or tone? Is there any importance in this normalization considering like the three sources of data are quite distant?
Yeah, exactly. I think that was one of the motivations to actually look at different domains. But and even within these domains, for archive, for example, we did not focus on just computer science. We focused on a lot of different kinds of domains of articles. Similarly, for Wikipedia, we tried to cover, I think, around 30 to 40 different topics, simply because they come out of different audiences, or different pools of writers have contributed to these separately. For news, we were very restricted because there are not a lot of sources where you can gather news articles from. And I believe the news articles might have the most limited pool of authors. But we tried to, mostly diversify by being very broad in terms of what domains we choose. But theoretically, yes, there always might be some bias, depending on, let's say, if we were just focused on within archive, if we were just focused on, NLP papers, yes, that might restrict the author pool a lot. But if I remember correctly, the data set that we collected came from at least 4,000 to 5,000 different authors. That is just for archive. For Wikipedia, it might be even larger. So yeah. Sophia, you're on mute.
Oh, yeah. How does Grammarly's taxonomy-based approach stack against the edit endpoint of OpenAI's DaVinci?
Interesting question. So this work is not something that the Grammarly product offers. This is just an independent academic research that I just presented. And yeah, it's really dependent on, I think I forgot to, I mentioned this in the beginning, that even if you read the GPT-4 paper that came out of Azure, they have also mentioned that, yes, it's the biggest model that exists today, or one of the biggest models that exists today, and can perform high quality revisions. But this element of iterativeness is what makes it limiting. I can share more details later on. And the other thing is, there have been a couple of papers that came out actually just last week or within the past 1 or 2 weeks, comparing Grammarly to ChatGPT and so on. And yeah, that also provides some interesting insights into how those models are, how even ChatGPT is limited when it comes to such tasks.
Do you guys have questions? Feel free to unmute yourself.
Well, hi, this is Eric. I have a question. I'm sorry I didn't see all of the presentation, but I'm an active Grammarly user and I love it. But I've also been experimenting with ChatGPT, and I was wondering if you know this, I'm not sure, but if Grammarly is thinking of providing more like ChatGPT like features where Grammarly can actually help you write your document versus just checking grammar.
Yeah, obviously we're all very excited by the possibilities that these large language models and their generative capabilities provide. And in fact, yeah, you might want to look into Grammarly Go, which is very much related to what you just asked. We are going to launch this new set of products and features which will help address the blank page problem and so on, powered by generative AI models.
Oh, that's awesome. Thank you. I'll look forward to using that.
Yeah.
Thanks, Eric, and great to see you. Eric is also one of the core members of our community. Do we have other questions?
Yeah, I have one. So, Vipul, thank you so much for the great presentation and the awesome work. I just want to ask that are you planning to have to integrate some kind of dedicated or focused edit mode into this taxonomy based approach? Like if I want to, if some user want to edit the input in a certain type of tone that they want, like I want to edit in a scientific tone or something like that.
Interesting. So you kind of are touching upon adding this dimension of personalization into this revision process.
Yes. Instead of the model driving the iterative edits, can the user have the option to switch the tone of the edits?
Interesting. Yeah, I think it should be fairly straightforward by, in this case, at a very basic level, we can suppress the edit intentions that are detected, which are of a certain style, and yeah, the revision generator will not generate those revisions. Similarly, yeah, I think that's how it could be done. But I think figuring out which like these edits are appropriate for a scientific domain, these edits are appropriate for news domain. Yes, even that can be done by adapting that, by including that information in the training data itself. in as part of the context in these, maybe by using prefixes in these sentences and so on. So yeah, it can be done, but I'm not sure, like based on the future work that I talked about, we'll get to it. But yes, it certainly can be done. Another thing is the user always has the preference. They can choose to reject edits.
Awesome. Thanks.
I see Shane is asking what other features users are asking for.
Is that for Grammarly or?
Shane, do you want to elaborate on your question? I assume for this particular.
Yeah, so this is actually currently still academic research. So once we validate more of these ideas, I think then we will think of figuring out how they can be integrated into the product. But the focus currently is to explore the advances in NLP research and apply those on to the domain of text editing.
But do you guys have sort of understanding how it will be sort of implemented into product? Basically, like as a user, what kind of experience I will have with this kind of tool?
I think so. This research is almost like this work has been going on for almost 2 years, and I think in that time, a lot has changed thanks to generative AI. So I think we do have some ideas, but I'm not sure I'll be able to share them just yet.
Yeah, understand. How Grammarly provide relevant grammar answers like Google search provide 60% relevant search?
So I'm not sure I fully understand your question, but if it's about
Aftak, do you want to ask your question directly and elaborate on your question?
Yeah, sure. It's I'm asking regarding relevant, how much relevant Grammarly providing to us. So example, like I attend the Google search conference. They're talking about the Google search providing to the user 60% search results. Okay, so every year they're removing the irrelevant search result. So like this way they work. Similarly, how Grammarly like providing grammar, improving the grammar correctly, like how much is percentage or relevant.
So if I understand correctly, these are like, you're talking about evaluation. Search is evaluated in terms of relevance, as does any news feed. For a task like grammatical error correction, relevance is not so much like if you talk about what's the quality of the corrected text, it does not fall so much in the realm of search. We don't think about it in terms of relevance. It's more in terms of quality. How well is the corrected text aligned with expert or expert annotations or some predefined text quality metrics. Fortunately, grammatical error correction has some pretty well-established automatic metrics. There's GLUE score, there's M2 score, there's F0.5. So these are automatic metrics, but we also rely on human evaluations to evaluate the quality of grammatical error correction. The only place where it really, where we kind of think in terms of relevance is personalization, because a person who speaks, I don't know, British English will make different kinds of errors. A person who speaks American English will make different kinds of errors. So yes, in that case, the suggestions have to be relevant, and that's something that Grammarly also provides.
What datasets do you wish you had?
That's a hard question. Like, that's a vague question. I mean, I'm not sure. I think we pretty much work with open data sets that are openly available. I guess you can think of a limitation of this work as, most of the data sets that you see, Wikipedia, archive, are very formal. So if maybe there were data sets which were openly available, which also represented informal writing or more personal writing, I think that would have helped this work as well. And yeah, that's it.
Okay, I see one question. When will Grammarly Go be released? Will it be for all Grammarly subscription users or for only premium subscribers?
I'm not sure I have like all the answers here for this question, but stay tuned. This will be released fairly soon.
Mm-hmm.
And I really appreciate your excitement for it as well. The team worked very hard to put this together.
Yeah, I can imagine. Yeah.
Sophia, can I please have one?
Sure. So,
okay, Vipul, you mentioned that you are actually working with an edit intention classifier as well. So have you guys also tried with getting topic modeling of the user input so that you have a better idea of what the text is about and can have better edit options available for that prompt?
Yeah, that's an interesting question. The thing is that we just wanted to build something that works across all kinds of domains and topics. So just by collecting data from different domains, Wikipedia, scientific papers, and news, that's what we are claiming, that it reflects different topics, it reflects different writing styles, it reflects different domains and writing patterns. But what we are proposing is generic enough that whatever domain or topic you provided, the system will generate edits which improve the quality of the text.